The equation of motion of a particle is s is equal to t cubed minus 3t, where s is in meters and t is in seconds. Find A, the velocity and acceleration as functions of t. Okay, firstly, what is velocity? Well, if we go to the top right, velocity is just speed. Okay, so we know what velocity means now. Great, but we still don't know what the question is asking. Well, we know that speed is just a change in the position, or a rate of change in the position. But what does that mean? Okay, we know what a rate of change is. It's how fast something is changing. But what is a position? Well, our position is just our curve. This is our position curve, s. And what is s? T cubed minus 3t. So, well, okay, we know that our speed is just our rate of change in s. But how does that help us answer our question? Well, we know that if we want to get the rate of change of something, we can take the first derivative. So let's do that. Let's take the first derivative of s in terms of time. So the first derivative of s, well, s is not really capital, so s in terms of time. Now what would that be? So using our power rule, we would get 3t squared minus 3. Okay, great. And that's the answer. This is our function of speed in terms of time. Now, they also wanted acceleration. Well, what is acceleration? Well, I said that speed is just the rate of change in your position. Okay. Well, acceleration is just the rate of change in speed. Okay. And we know that to get the rate of change of something, we take the derivative. So let's do that. Let's take the derivative of this. Or we could say the second derivative of s. So let's do that. Let's use some fancy notation. Let's say taking the second derivative of s in terms of time for the second time. So this just means the second derivative of s. So what would that be? If we just take the derivative of this, we would just get 6t. And there you go. This is our function of acceleration in terms of time. And we can just, well, there you go. That's the answer for A. So next, B. And B says the acceleration after 2 seconds. Okay. Well, I've just calculated my function of acceleration, and I know that t is in terms of seconds. So I'm going to plug in 2 where t is. So, and that'll be 12 meters a second, because we know that this is moving in terms of meters every second, as stated in the question, where s is in meters. Okay, lastly, C. So this so far not so bad. So C says the acceleration when the velocity is 0. Okay, hold up. The acceleration when the velocity is 0. Let's focus on the second part first. Let's say, okay, I want my speed to be 0, and I have a function of speed. So let's set that to 0. Let's say 3t squared minus 3 is 0, because my velocity is 0, and this is my velocity. Okay, so, well, I can say, let me just take out a 3. Wouldn't really affect anything because we have a 0 on the other side. So that would be t squared minus 1 is equal to 0. And we can recognize that we have a difference of 2 squares, so we can say t plus 1, t minus 1, and then this would be t plus 1 is 0, t minus 1 is 0, t is minus 1, or t is 1. Now let's think about this carefully. We have two t values, two time values, where our speed is 0, at -1 or at 1. Well, can my time be -1? Can I say at -1 second or at -1 second my speed was 0? No, because we can't count time negatively. You can't say minus 2, -1, 0, 1, 2. No, it's 0, 1, 2, 3, and then so on. So, well, we can say, well, time cannot be negative, so t cannot be -1. So then we can say, therefore, t is 1 second. So we know now that at 1 second, my velocity was 0. So we know the second part of the question. When our velocity is 0, we know what time that happens. At 1 second, our velocity is 0. Okay, but they want the acceleration. So we have our time, and we have a equation which describes our acceleration. So at 1 second, we can just plug in 1, and we would get that our acceleration was 6 meters a second at 1 second.